Well, hi, good morning, and thanks so much for joining me here. Today is the 25th of July, and day two on this radio. So my plan today is pretty simple. I just want to go through and test the 5 vacuum tubes that are in this radio, and maybe we'll find out something about why the output level is low right from finding a weak tube. So let's see if I can get my tester up here. Go. Okay, so I think the first tube we want to do, I want to start right with the output tube. This receiver has no rectifier tube. It uses solid state rectification, so we're gonna start with this guy. Now, I also have not wiggled the tubes in the tube sockets, which is just a simple way to kind of improve the contact. I hadn't done that. Maybe I should have done that when I was initially operating the radio, because perhaps just a bad contact with one of these tubes would cause the low output. And it's a snap to find it, right? Just wiggle the tubes and see what happens. But I didn't. So you have a great big EL84. It's big because it needs a lot of plate surface area and the like to convey the current that it wants to flow through here. This is the tube that drives the speaker, of course. And it's also big because it's a hot one. Why is it hot? Again, it's trying to maximize the current flow. Don't put it in there just yet, Jim. That's not a smart move. So we'll look it up here. EL84. Where am I going to find that now? So I have enough tube testers that... Oh yeah, if I can't remember. EL... Did I say 84? 84. EL... it doesn't appear here. EL95. So these tubes usually have a North American version, sometimes written right on it, EL85. I'll have to find out what an EL84 rather is. So just, you know what, I'm just going to pop here on the internet very quickly on my computer over here, and I'm just going to type in EL85, 85, 84, what am I doing? 84 sub, and we'll find out it's a 6BQ5. Okay, that's not a surprise to me. So 6BQ5, so we'll set this to 6BQ5. 6B. Oh my gosh, they got to be here. 6BQ5. I should have really studied the alphabet better when I was in school. There, it says EL84 right there. There we go. Great. 6.3 volts, signal level 4. Bias is 20 high. 05176. 05176. 0304. 0304. 30 to make the meter tell the truth. F plate connection, and it's 1460 on this meter. 1460 puts us, well, that's 1500 right in the middle. So 1460 almost up to the middle. Okay, 6.3 is correct. 6.3. In you go. On we go. So this particular tester is a, what does it say right on it? Mutual conductance tube checker. Mutual conductance. So this guy is a level up tube tester, one level up from the poorest kind. And this one will actually attempt the measurement of the mutual conductance, the transconductance, the GM. Just fooling with the lighting here to try to get this more visible while it's warming up. That's a little more visible there. Still not very good, but I think you can kind of see the pointer. Okay, so we'll check for shorts. Watching the pointer. Nothing showing up. So I'm going to hit the test button here, and the needle should go right up to the middle. So we're reading 1300, and the reject point is 1460. Right. Right on. So, you know, in a perfect world, we would throw that tube away and put a new one in. In the world we're in right now, it wouldn't be wise to throw this away based on this one test. Let's do a little sensitivity testing. So I vary the bias a little bit. So you can see there's quite a very small movement over here. Can make the test go good. So, you know, depending upon the precision of the calibration of the unit, and likewise meter sensitivity, even that one. So, you know, so if these two dials are just a little bit of calibration, this thing may show, you know, on the wrong side of pass. So that's why I would not reject this, but I'll make a note. Gotta watch out for these guys, they get hot. Have to make a note. If we can find some other reason for a low output, this tube will come up on the list again. But for now, I think this tube is weak in the sense, or weak to a degree that you would just compensate with more volume. Now, I think I had the volume up right full. There's too many other bad parts in here to jump to the conclusion that that tube has to go. And one of the things you're doing with the tube tester is you're finding out, does the tube work at all? EABC 80, I'm sure that is. The number's wiped off, but I'm pretty sure that's an 80. EABC 80. On the back of this radio is a tube chart that could hardly be seen, but if I just hold it right, you see EABC 80 right there. Okay. Now, how am I going to do that on here? Does it show? Probably roll charts. Great things that you can hate. E, A, E, right at the end of the thing. EABC 80. It's there. Great. Okay, so unfortunately, let me just change the lighting again. Right. Well, not quite like that. Let's try this. It's maybe a little bit better. Okay, EABC 80, 6.3, signal level is 1. 25L, 00076. There's a bunch of tests for this tube. 00076. 0153. 0153. In the European numbering system for tubes, there's a stronger attempt to put some intelligence into the tube name. So when you see E, A, B, C, that's 4, yeah, that's right, 4 letters, that's kind of an indication that there's a lot going on in this tube. More letters, more stuff going on. Did I finish this, or did I stop right in the middle of it? Shame on me, I stopped right in the middle of it. How do I know the rocket's ready to blast off now? I'll start the countdown over again. 32. F. This is very important. EABC 80. We're testing the triode first. Right. Let's plug it in. Lots of pins. There it goes. You can see the light dim briefly. Dim. That's a dim bulb system. Not really. No, that's not. No, that's not true. Pretty bright. Okay, checking for shorts. Nope, that's normal. Ready now, 900, so right up around here. Yeah, so just above 900 on here. We'll do that little sensitivity thing again just for comparison. Look at that. It's extremely sensitive to the setting of this control. So again, the calibration of my unit is critical. And 32, is that what that was supposed to be? 32, yeah. 32. Not quite as sensitive, but still. 32, 25, and now it's warmed up a bit more. We're actually getting up to the 1,000 mark. That tests good. So now there's two diodes to test. 3100. Oh, did anybody see that? You know what went through my head just before I did that? Is this the tester where you gotta pull the tube out before you change the settings? And the answer is yes, this is the tester. I may have damaged this tube. So, hold it for it. Let's retest what we got here because I may have blowed it up just now. I'm sure the blue came out on the... did I test anything? Change anything else? Am I lost? My mind is gone. It's even better. Okay, pull the tube out. Yeah, this tube tester, you cannot change settings while the tube's in place. Isn't that a drag? So those stay the same. We switch to 31. 31. I was almost there. I was there. 31. Let's stick it back in. Everything you do with this old equipment and everything you do with everything has an element of risk with it. And you might think the risk, chances of something happening are low. But if the unlikely thing does happen, the cost is huge. 45. You need to really think about these things. A. I guess I can change this one with the tube in. Diode number 1. So probably changing these settings is a bad move because they are involved with the heater. And probably as I change this, I swung something past the heater terminal, or who knows, I don't know. Shame on me in any case. I'm going to beat myself up all day over that. This isn't right. 31 is supposed to be 3100. Jim, you better stop talking because so you're going to talk your way right into a bad problem. Okay, so now it's A. Let's go to 00076, 3100. Okay, 45. Got it. A, and no issues with the bias. Diode number 1. So there's a diode OK line right here. You can't see it at all on the camera, but there's a mark here. If you just get above the mark, diode OK. There's a diode check here. Let's just do the short thing again. Diode. Oh, it's just on the line of OK. It's just right. You couldn't get it any lower. Now there's another diode to check here. Pull that out. P3176. P3176. 0K00. 0K00. Okay. You can actually see in this tube there's 3 different sections inside it. There's three tubes in one. Probably reduces the or increases the chance of failure since there's 3 in here instead of just 1. You got 3 things to fail. Let's double check while I'm waiting here so I don't make a mistake. Hey, here's something different. 38. 38A. There's 3 diodes in here. So we tested the 1 diode, now we're going to test diode 2 and diode 3. We're all set. Just go through the short thing just in case. Diodes, okay, well up above the line this time. And the other last diode diode 2 and 3, PK and PK, PK, P. Next diode, very good. One testing a little low. So the diode in here is being used to rectify and ultimately uncover the audio signal that's in the AM radio. So if it's weak, that might cause a weak output. But it's not terribly weak. It's just at the bottom of the line here. It's not garbage can weak, that's for sure. So another one to make a note of. If we can't get rid of the weakness, weak volume some other way, we have two tubes now that we might want to consider. This weakness looked like, I'm looking up here, the way this tube tested, it would suggest the diode for the AM radio is bad and the diodes used for the FM side are good. EF89, so I think that's a 6BA6, isn't it? Maybe I've got it in here. EF89, there it is. 6DA6 is the North American version. Away we go. 6.3, 2, 34L, 34L, 05176, 05176. Now I'm not double checking these this time because you're watching, so I'm counting on you to spot my mistakes. 342. So because you're being silent, I'm just carrying on here. 34. Maybe you're not being silent because I can't hear your yelling and screaming at your screen. Okay, let's double check because I was talking the whole time there. 6.3, 2, 34L, 05176, 05176. See, I'm not relying on you this time. 0, 3, 4, 2, because I can't hear a thing you're saying. 34D. We're ready. So this is a pentode. It has 3 grids in it, which enables it to operate at higher frequencies. That's the reason you're using a pentode. Get a screen grid in there. It allows you to go higher frequency. Okay, any shorts? Nope. The test result should be 1170. So it's got to get up around here to be good. Oh, way over there. So good strong tube. This tube's important because it's the amplifier in the IF part of the radio, and it's responsible for a lot of the strength of the radio's reception. A lot of amplification occurs in this tube. Now we'll go to the front end tube. This is the mixer tube here. It's another busy tube. What's it called? 6AJ8. So this has the North American name on it, and there's a good chance this is a replacement. The original one says made in England. It's a good chance this is a replacement. 6AJ8. I don't think I've ever heard of that tube. 6AJ8. Okay. Lovely roll chart. 6A. There we are. 6AJ. EFG86AJ8, or an ECH81. So probably originally there was a tube in there with ECH81 written on it, and it got replaced with this one, 6AJ8. 6.3, big signal 4, 15L, 00176, 00176. 0035, 0035, 46. D. Two tests on this tube. We're testing the triode first. 6, 15. I'm just trying to confuse myself before I hit the button. Good. That's confused. I'm confused enough. The world is a very chaotic place, and human beings, like many animals, are able to operate quite nicely in a chaotic place, making our decisions with insufficient information all the time, and somehow muddling through. That's because of the fantastic power of our brains, mine excluded. For some reason I gave that little speech. Okay, we're ready now to hit the button 1180. So again, right up in this, right up about here. Way over the mark. Great. And the last tube test. So yeah, because this is a fairly new tube compared to the other ones. Based on my theory. So tube out. Make the same mistake twice. I bet you can change these, but you can't change these. That's what we guess here. 4, 5, 1, 7, 6. 4, 5, 1, 7, 6. 4, 5, 1, 7, 6. 3200. 3200. 39. And D. Did I do that? Did I stay on the right line now? I think I did. 4, 5, 1, 7, 6. 4, 5, 1, 7. Yeah. 39D. This is a heptode. For some reason it says heptode triode. Don't understand why it's got that in there. I won't think about it much. Correct voltage on the machine, of course. 6.3. In you go. Did I say there's one test? Hold on. Hold on a second. I think I read half of one line, half of another line here. That's exactly what I did. I tell you, boy, if there's any way to make a mistake, I find it. 00176. Wow. So what I did is I actually set it for the second line. 4, 5, 6. 30, that's what I did. I just set it for the second line. 39. That's okay. We can go ahead and we'll just test the second line first. I often wonder if is it making these videos that makes me make stupid mistakes, and I can honestly tell you, no. No, I'm quite capable of making stupid mistakes, video on or video off. The difference is, and you should think about this, the mistakes I make that don't get caught on video, I never know about, and I feel great. For instance, I never run stop signs, I never run red lights, and I'll bet you're exactly the same. You never run stop signs, and you never run red lights, as far as you know. And you don't know far. We all run stop signs and red lights once in a long while. Okay, I don't run red lights. I don't run red lights. But how can you know? You can't know the mistake you're making unless it's apparent the moment you make it, or someone comes and tells you. So if you avoid that, if you avoid supervision, avoid people talking to you, and for God's sakes don't make videos of the stuff you're doing, you'll live a glorious life in which you never make a mistake. And by the way, if you do make a mistake and you realize it, there's ways to blame it on other people. You can immediately blame it on other people. There's always somebody you can blame it on somewhere. And live your life thinking you're not human. Boy, I'm really speechy this morning, aren't I? 3200. Okay. I just did this. I'm going to do it again because I erased my memory. And now we're shooting for 780. 780. 780 is about here. Way over. She's a gloriously good tube. And we got one more to do. This is the FM tube. ECC 85, no surprise in that. Let's see if we can find it on here. ECC 85. 6AQ5, 6AQ8. This one is, yeah, I already looked at it. This is the original. So this is probably the original. These tubes I find are often weak in these radios. We will see. 6.3, 4, 21L, 35176, 35176, PGK1, PGK1, 37, F, twin triode, P1G1K1, that's these switches here, for one test, then we flip them for the other test. Incidentally, when I give these numbers, a rejection point 1250 for this tube, that is not the mutual conductance or transconductance measurement. To get the actual measurement, you would take whatever the meter comes up to, and in this case, you multiply it by 3. It shows it right, you can't see what I'm doing here. Right here, it shows it right here. It says X3, that means times 3. So what they realized with this tube tester is if they made it necessary for you to make mental calculations, or how about me make mental calculations at the time I'm doing the test, I'll probably make a mistake. So instead, the number they give, the 1250 rejection point, is just a straight read off of here. So, you know, if you hear me say a number and then you're opening up your tube book and going, no, the GM is 3 times that. Well, yeah, it is. Tube in. I could have put the tube in and had it warming up all this time. So this guy is, as I said, it's the FM tube. This is a dual triode. That's why we do this thing and get the other triode tested. Any leaks? Nope. And the expected is going to be at 1250. I said that a couple times. 1250 puts it up about here. Hey, what happened there? We got absolutely nothing. This is in a working radio. Hold it for it. Something wrong. Start over. 6.3, 4, 21L, 35176, 35176, PGK1, PGK1, 37, everything's correct. F, it's correct. Okay, so maybe a socket problem here. Okay, so we'll find out. Put it on again and we'll go like this, and there it goes. Yeah, I've got socket problems here. So yeah, it takes a lot for me to reject a tube out of these tube testers. When the tube tester says it's bad, I say I doubt it. So we're well above the 1250, not well above, we're at the 1250. The other side, let's see. And almost exactly the same reading. It's a good tube, radio works. If this tube were really bad, there just wouldn't be any FM. And there we have it. What did we find out? We found out all tubes working. Chances are, there is a chance, the output tube is weak enough that the output's weakened because of it. There's also a chance that the tube that's driving the output tube is a little bit weak here, if I remember right. Wasn't it? No, it was the diode that was showing up weak. Probably not a source of the weakness. The weakness is almost certainly coming from large dust bunnies and bad capacitors. That's probably my guess. I can vacuum out the dust bunnies. I'll have to change the capacitors, and that's about as far as I can get. So I think that's it for today, because today, oh, I feel so guilty, is another absolutely beautiful day to be outside. It's really not the day to be inside. Here, see if I can give you a look at what it's like out there. it is. It's not very good, but that's our garden there in the backyard, our tomato plants, which are growing like wild guys. Everything is growing beautifully because the weather is so fantastic, and that's where I'm heading next. So thanks for watching. That's all I'm going to do today. Tomorrow we'll start working on these capacitors and see if we can't find something that's making this radio weak. So thank you very much for watching, and I'll see you tomorrow.